And now, for question 10. Which of the following will affect the position of a chemical equilibrium? Okay, so when we're talking about the equilibrium, we're talking about going from, oh, that is not what I wanted to do. We're talking about going from reactant forward, backward to product. And of course, the equilibrium is given to us by concentration of our products over the concentration of reactants. And so we want to know which of these things are going to be able to affect the ratio of products to reactants. And does a catalyst affect that? No. A catalyst does not affect what ratio this thing has. What it affects is how fast we get to reactant and product. So a catalyst has no effect. If we add additional gas to a closed vessel, so if I have one of these being a gas or one of those being a gas, it depends on where we are, exactly what that equilibrium is. That will determine what happens. When we add additional gas, the equilibrium tries to minimize the additional pressure by shifting towards the side of the reaction that has the least number of moles of gas. So we've talked about a couple of gas things before. We talked about O2 plus H2O going to H2O2, right? So we had O2 plus H2O going to H2O2. It's 2 of those. That gives me 2, 4, 4, 2 of those. So what you can see here is I have 3 moles of gas on this side and only 2 moles of gas on this side. So if I were to add additional gas to this equilibrium would shift in this direction to minimize the pressure that exists there. So adding gas can have an effect. When it doesn't have an effect is if it's not part of the equilibrium. If we don't have any gases that are part of the equilibrium that we're looking at, that's not going to help. It's not going to change anything. Now, changing the temperature. What was the one thing that I said could change the value of the equilibrium constant? That's changing temperature. So I'm going to delta T changes KEQ. That is very true. Now, what happens with some of the product? Let me take a step back. When we do this shift, does that actually change the ratio of products to reactants? Does it? Does it change that? Really, it doesn't. What happens is we disturb our equilibrium when we add that gas to it, and then to get back to that equilibrium, that's how we have to do the shift. But it isn't going to change that ratio when we're at equilibrium. So, what about removing some of the product? What did we talk about when we talked about removing the product? So if I were to take this H2O2 and yank it out of here, right? That would shift this and it would move it in the forward direction. But again, after we've shifted, we will get back to equilibrium, and that equilibrium ratio is going to be exactly the same as it was before. So the only thing in this list that will change the position of the equilibrium is the temperature. And that is the only thing that can change it. It's not just out of this list. It's the only thing that can change it. Okay? So that's number 10. I'm going to go ahead and stop sharing. And I'll stop the recorder, and I'll see you later.